To determine how fast something is going, we use a measurement called speed. Speed is an expression of distance as it relates to time. So if I say that a car is going a certain number of miles per hour, my miles is my unit of distance, and the per hour is my unit of time. Speed can be expressed in miles per hour, kilometers per hour, feet per second. Let's look at an example of a car moving at 50 miles per hour. So we might see this written as 50 miles per hour. Or we might see it written as 50 miles per hour, abbreviated as miles per hour, or sometimes in some problems we'll see it as mph, miles per hour. So if I have a car that's going at a speed of 50 miles per hour, this means that the car will travel 50 miles in 1 hour. If I maintain this same speed for a full hour going down the road, I will cover a distance of 50 miles. A car going 70 miles per hour is going faster than a car moving at 50 miles per hour, because a car going 70 miles per hour will cover 70 miles in 1 hour. Similarly, a car going only 30 miles per hour will only cover 30 miles in 1 hour. So it's going slower than both of these examples. The formula for speed as it relates to distance and time looks like this. Speed equals d for distance divided by t for time. So let's look at an example. Bruce drove his car 120 miles in 2 hours. Find the speed that Bruce drove. So what I want to do to find the speed, start with my formula, S equals, I need the distance, and so I come into my problem and I see that the distance is 120 miles. So I'm going to put that on top, 120 miles over time, and I look for the time in my problem, 2 hours. So I put my 2 hours here, and I solve the problem. 120 divided by 2 equals 60. So my speed is 60, and I always have to label my answer. I can't just leave it 60. I need to say 60 miles per hour. So the solution to my problem is that the speed that Bruce drove his car was a speed of 60 miles per hour. Let's look at another example using speed. Charles walked at 4 miles per hour for 3 hours. And our question is, how far did he walk? So I can see I've got speed and I've got time, and I want to find distance. So to find the answer to this problem when we already know the speed and the time, we're going to return to our formula of speed equals distance divided by time. But in this case, I want to find distance. And so I need to rearrange my formula so that distance, or d, is all alone by itself on one side of the equal sign. So right now I look at my d and I think, uh-oh, there's a t in the way. It's attached to the d by division, and so to unattach it, I'm going to do the opposite operation, and I'm going to multiply by t. Whatever I do to one side of an equation, I have to do to the other. And so I can cancel out my t's here, and now I reached my goal of having my d all alone by itself on one side of the equal sign. Let me rearrange this though so it looks a little more familiar. So now we've got distance equals time times speed. So to find the distance, when I know the time and the speed, I just simply multiply time times speed. So let's look in our example for time. Time, we have 3 hours. So 3 hours is our time, and we're going to multiply that by the speed that Charles walked, 4 miles per hour. So times 4 miles per hour. So when I go through and multiply this, 3 times 4 equals 12. I've got hours here in the numerator and hours here in the denominator, so those two cancel out, and I end up with my answer of 12 miles. So the distance that Charles walked when he was walking at 4 miles per hour for 3 hours is he covered a distance of 12 miles. Let's look at another example of speed, distance, and time. Danny threw a ball at 120 feet per second. How long did it take the ball to travel 90 feet? So I'm still going to look at my formula and use my formula of S equals D over T, but let's look at the information that we have in our problem. We have been given 120 feet per second, which is the speed, and we've also been given 90 feet, which is the distance. And our question is, how long did it take? So we need to find time in this example. So I'm going to rearrange my S equals D over T formula so that I have T all alone by itself on one side of the equal sign. So what I want to do is I want to first of all multiply both sides of my equation by T. This cancels this T out of this side because any number over itself is just 1. So I can cancel that out. And by multiplying this side by T, whatever I do to one side of an equation, I have to do to the other. So when I multiply this side by T, it gets my T for time up in the numerator. Now, I want this T all alone by itself, but I still have one thing in the way, and that is this S. The S is attached to the T by multiplication. So to unattach it, I'm going to use the opposite operation, which is division. So I'm going to divide this by S, and whatever I do to one side of an equation, I have to do to the other. So I have to come over here and divide this side by S as well. Anything over itself just equals 1, so I can cancel that out, and I've reached my goal. T is all alone by itself on this side of the equal sign, and I've got T equals D over S. So let me rewrite that as T equals D over S. So anytime I'm looking for time, I can take distance divided by speed and find the time. So let's plug our information from our example into our new formula here. So distance is a distance of 90 feet. So I'm going to plug 90 feet here into my numerator, and my speed in my problem up here is 120 feet per second. So here in my denominator, I'll put 120 feet per second. So to find the time, I'm going to divide 90 divided by 120. So time equals 0.75 seconds. So the answer to my problem, how long did it take the ball to travel 90 feet? It took 0.75 seconds.